1. Introduction to arrays and their purpose. In any programming language, when you want to store data, you have choices. You could store individual values in variables, or you could group related values together into one logical structure. Imagine you're developing a program to store the scores of 50 students. You could create 50 separate variables, but that's tedious, hard to maintain, and not scalable. This is where arrays come in. An array is a data structure that stores multiple values of the same type in one variable name, each accessible by an index number. Think of it like a row of mailboxes, each labeled with a number, where you can store and retrieve a specific piece of data. Arrays are useful because they organize related data together, make it easy to process large amounts of data in loops, provide predictable indexing for quick access. In OOBasic 2, arrays are versatile. You can declare them in different ways, fill them with values, retrieve values, and even pass them to methods for processing. 2. Declaring, allocating, and initializing arrays. Declaring an array. In OOBasic 2, you must tell the program that a variable is an array and what type of data it will store, integers, strings, floating point numbers, and so on. This step is called declaration. Allocating an array. Once declared, you need to reserve memory for it. This is the allocation step. When you allocate, you specify the number of elements the array will hold. Initializing an array. Initialization means setting the initial values of the array elements. You can do this in one step when declaring the array, or you can assign values one at a time after the array has been allocated. Example scenario. Declare, I will have an array of integers. Allocate, this array will have space for 10 integers. Initialize, the first integer will be 5, the second will be 12, and so on. One of the advantages of OOBasic 2 is that you can also use shorthand initialization, where declaration, allocation, and initialization happen in a single line. This is handy for small sets of predefined data. 3. Accessing and modifying elements. An array element is accessed by referring to its index. Indexing starts at 0, so in an array of 5 elements, the first element is at index 0, the second at index 1, and the last at index 4. To read a value, you simply refer to the array name and the index. To modify a value, you assign a new value to that index. For example, if you stored student scores in an array called scores, you could retrieve the third student score and update it if needed. Understanding indexing is critical. Many errors in beginner programming come from off-by-one errors, where you accidentally try to access index -1 or an index greater than the array size. 4. Iterating through arrays. Iteration means going through each element of an array one at a time. This is where arrays become truly powerful. In OOBasic 2, you can use a for loop to start at the first index, process each element, and stop at the last index. This allows you to apply the same operation, like adding up all numbers or printing all names, without manually writing a line for each element. You can also use for each loops, which simplify iteration by automatically moving through all elements without worrying about index numbers. However, for each loops don't allow you to easily change the index or skip around. 5. Sorting and searching arrays. Two common operations on arrays are sorting and searching. Sorting arranges elements in a specific order, usually ascending or descending. This makes data easier to read and also speeds up searching in certain cases. Searching is finding a particular value in the array. A linear search checks each element one by one until it finds a match. A binary search is much faster but only works if the array is already sorted. It repeatedly splits the array in half until it finds the desired value. In OOBasic 2, there are built-in functions and library methods for both sorting and searching, so you don't always have to write the algorithms yourself. 6. Declaring and manipulating multidimensional arrays. So far, we've discussed one-dimensional arrays, a single row of elements. But sometimes, you need to represent data in more than one dimension, like a table or a grid. Multidimensional arrays allow you to do this. The most common is the two-dimensional array, which you can think of as rows and columns, like a spreadsheet. You declare them by specifying more than one index. For example, a 3x4 array has 3 rows and 4 columns, for a total of 12 elements. Accessing them works the same way as one-dimensional arrays, but you must provide both indexes, one for the row, one for the column. These arrays are essential for representing things like game boards, seating arrangements, or matrices in mathematical computations. 7. Passing arrays to methods. Arrays become even more useful when you can pass them to methods. This allows you to create reusable code that can process different sets of data without rewriting the logic. When passing arrays to methods in OOBasic 2, you can choose to pass by value or by reference. By value means the method gets a copy of the array reference but can't change which array the caller is using. By reference means the method can modify the original array's content. Passing arrays by reference is common when you want the method to sort the array or update its values. 8. Practical applications of arrays in programming. Arrays are everywhere in programming. Let's look at some common use cases. Storing sensor readings in digital electronics projects. Maintaining a list of connected devices in a network application. Holding frames of image data for processing in a graphics program. Keeping a sequence of instructions in a compiler or interpreter. Simulating digital logic patterns in hardware testing. In digital electronics, arrays can be used to model the state of each pin in a microcontroller. In computer programming, they form the foundation for more advanced data structures like stacks, queues, and lists. Module 1 Summary. In this module, we learn what arrays are and why they are important. Cover declaring, allocating, and initializing arrays. Practiced accessing and modifying elements. Understood how to iterate through arrays efficiently. Explored sorting and searching techniques. Worked with multidimensional arrays. Learned how to pass arrays to methods. Discussed real-world applications in both programming and electronics contexts. By now, you should be able to confidently create and use arrays in OOBasic 2, preparing you for the object-oriented concepts we'll explore in Module 2.